Siemens KNX Presence Detector Wide. Application Temperature Control. A temperature sensor mounted on the ceiling must be specially set up to correctly control the room temperature despite the unusual installation position. This means that the measured values recorded by the sensor must correspond as closely as possible to the actual conditions in the control range. Therefore, it must be ensured that only a constant temperature offset occurs at the installation location, which can then be compensated for using the offset parameter on the temperature measurement page. Types of control and their application. The Siemens Presence Detectors Wide support the PI control as well as the two-point switching control. In PI control, a distinction is made between PI continuous and PI switching. PI continuous is mainly used for servomotor-driven valve actuators, PI switching for electrothermal actuators. In both cases, a control accuracy in steps of 0.1 Kelvin is possible. Two-point switching controllers are quick and easy to configure, but require a larger hysteresis. This is not disturbing in uninhabited ancillary places such as warehouses, storage rooms, corridors and staircases, but is generally not suitable for rooms used by humans. Control temperature absolute or relative. How should the room temperature be controlled? Relative via setpoint shift or operating modes, or absolute and direct via the setpoint temperature in Celsius. And how should the setpoints be adjusted? For each operating mode individually, or via the reference point basic setpoint. This controller offers all options. But let's look at the options of the controller using an example. Heating and cooling, PI continuous, with window contact evaluation. What are the minimum requirements? Which optional additional settings optimize the use of the temperature controller? For this, we go to the Temperature Control tab and select Heating and Cooling on the page of the same name. Switching between them should be automatic, which means, by the way, for the room installation, a 4-pipe system must be available so that no problems arise when switching from heating to cooling or vice versa. Next comes the page Room Operating Mode. Which operating mode does the controller start with after download or bus voltage recovery? A fixed operating mode or the last operation mode before bus voltage failure can be selected. Furthermore, we have to enable at least one window so that the controller can also be switched to building protection when it is open. A maximum of 4 windows are possible, which are evaluated as logical OR gates. If there is more than one window, we should also enable the window collective state further down, so that it can at least be visualized. The Windows status evaluation is mostly done via push-button interfaces or input contacts directly at the valve actuator. On the third page, I select the setpoint setting via the basic setpoint and the setpoint shift, which was introduced for KNX controllers a long time ago. Last but not least, the continuous output of the control value must be set in the Output tab. First, the control type has to be set to PI control. Then the control value is already correctly set to continuous by default. If desired, the control coefficients P and I can also be adjusted. For radiators, P equals 4 Kelvin and I equals 30 minutes are good values. Now, it's all about the group addresses. Which ones do you need at least, and which ones should be created additionally? The minimum required group addresses are in fact only the two control variables for the valve actuators and those for the window contact. However, the room temperature is then only controlled to the two preset constant set points for heating and cooling, and the respective building protection set point is activated when the window is open. Now to the further objects and group addresses, which make the temperature control comfortable and efficient. In our application example, it makes sense to set up a set point profile controlled by a timer. For this purpose, the room operation mode, automatic mode, is required. Today, such a controller is often operated via a visualization tool, a cell phone app, or a configurable display. For this purpose, the objects for the temperature set point and actual value, the manual operating mode setting, and the set point shift must be addressed. Before I describe the three other objects for optimal use of the temperature controller, we need to clarify the order of priorities. In this temperature controller, there are 6 priority levels. The lowest is automatic mode. The highest is continuous protection mode. Functions of higher priority override all functions below. Changes in the lower priorities are stored temporarily and reactivated when the priority above is terminated. A. COM4 extension, colloquially also called party button. If a logical one is sent to this object, the controller switches to the comfort mode for the parameterized overshoot time. This feature overrides, as priority 5, only the automatic mode. B. Permanent protection mode. In case of a longer absence, you should activate the permanent protection mode with a logical one to save energy. It has the highest priority and must be terminated with a 0 via this object. C. Presence. The presence object is predestined to be linked to the presence sensor also present in this device. As long as presence is set to 1, the controller is in comfort mode, unless it is running in manual mode, a window is open, or continuous protection mode is activated. The settings just discussed can be found on the room operating mode setting page. There, the objects are to be enabled and the time is to be entered for the COM4 extension. To round off the configuration, it is recommended that you activate the various status objects and also connect the controller on-off object. The latter object is self-explanatory. The status objects provide current setting data for visualizations or displays, at the latest after a bus interruption. By the way, the controller on-off object is always initiated with 1. That means switched on after download or bus voltage return. We have thus completed the temperature control block. Thank you very much for watching and listening. You are now able to configure the temperature controller of the Siemens Presence Detector Wide correctly.